Proseguiamo subito. Chiamo sul palco Andrea Bertini per un breve saluto, Product Owner and Business Development Manager di ING Direct, Main Partner di Cerved Next. Andrea Bertini, prego.
Grazie. Pronto?
Sì.
Ok, mi sentite? Grazie, buon pomeriggio a tutti, spero che vi stiate divertendo e che la giornata sia proficua. Allora, io sono Product Owner di ING per le piccole e medie imprese, quindi sono responsabile per tutte le soluzioni digitali per il mondo PMI, che sono la colonna portante dell'economia italiana. Ci troviamo di fronte a una vera e propria trasformazione digitale, ma questo rappresenta un'assoluta opportunità. Come ING sta cogliendo questa opportunità? Noi stiamo cercando di abilitare il cambiamento all'interno del settore bancario. Come lo stiamo facendo? In pratica stiamo costruendo un ecosistema digitale, una vera e propria piattaforma digitale e aperta in cui poter offrire ai nostri clienti i servizi che siano migliori, che siano semplici, trasparenti, innovativi, professionali e accessibili ovunque e in ogni momento, per permettere loro di, quello che diciamo noi, rimanere un passo avanti sia nella vita professionale che nella vita personale. Lo stiamo facendo sviluppando servizi nostri, con il nostro know-how, ma anche laddove vediamo che c'è la possibilità e che vale la pena, integrando soluzioni di terze parti, quindi soluzioni di fintech o di anche altri partner. Tutto questo è reso possibile grazie alla tecnologia, all'accesso ai dati in tempo reale. Un esempio concreto di questa strategia di open banking è quello che abbiamo fatto proprio nel comparto delle piccole e medie imprese. Prestito arancio business, un flash di che cosa si tratta prestito arancio business. In pratica è un instant lending, quindi in 10 minuti noi diamo una risposta immediata ad una richiesta di finanziamento ad una PMI. Lo facciamo collaborando con una fintech americana che è leader in America per soluzioni di working capital solution, che si tratta di Cabbage, e lo facciamo tramite una customer experience assolutamente unica e differenziante. È un processo totalmente paperless, totalmente digitale, dove non andiamo a chiedere nessun tipo di documentazione al cliente, se non il codice fiscale azienda, il suo codice fiscale del procuratore che fa la richiesta per conto dell'azienda, e di collegare almeno un conto corrente bancario alla piattaforma. Il nostro modello di credito quindi combina il meglio di quella che è l'analisi di valutazione tradizionale e ricostruiamo la dinamica finanziaria dei flussi di cassa del cliente in base alle informazioni che sono collegate alla piattaforma. Tutto questo in 10 minuti, tutto questo totalmente paperless, firma digitale del contratto, erogazione entro 48 ore. Questo è un esempio, credo molto importante, di come quindi la tecnologia aiuti oggi la banca, e non solo la banca, altri player, alla costruzione di soluzioni innovative che comunque apportino valore ai nostri clienti. L'altra cosa che ci tengo molto a dire, la metodologia non solo è innovativa la soluzione per appunto le cose che dicevamo, no? Il fatto che sia totalmente paperless, il modello di credito, ma anche come l'abbiamo sviluppato. L'abbiamo messa a terra abbastanza velocemente, quindi meno di 6 mesi, sviluppandolo con una metodologia che magari molti di voi già conoscono, Agile. Che cosa vuol dire Agile? Agile, la parola stessa dice agile, quindi andare a mettere in pista, quindi a implementare sul mercato una soluzione che reputiamo possa creare valore al cliente, e andandola a testare con il cliente stesso, quindi quello che noi chiamiamo build, measure, learn, quindi sulla base del feedback del cliente fare una continua validazione della soluzione con il cliente per poi andare a integrare e andare a migliorare il prodotto stesso. Quindi noi ogni 2 settimane in pratica c'è un nuovo rilascio, tale per cui andiamo a introdurre delle nuove caratteristiche, le cosiddette feature del prodotto, e andiamo a migliorare la soluzione, in base ovviamente anche al feedback che ci dà il cliente, che gioca un ruolo centrale. Quindi questo è un esempio. L'altra cosa che ci tengo a dire è sono molto fiero di lavorare per ING perché c'è proprio questa cultura di innovazione. Se vogliamo fare trasformazione digitale e innovazione, è molto importante che ci sia anche a livello manageriale, quindi da tutti i C-level all'organizzazione, sposare questo mindset, quindi sposare a livello di cultura aziendale questa metodologia, questa voglia di cambiare pelle e quindi di innovarsi in maniera continuativa. Grazie, spero appunto che stiate divertendo e che più che altro sia una giornata utile e proficua per tutti.
Grazie ad Andrea Bertini, grazie mille. Io adesso vi devo dare una notizia. Siamo stati massacrati. È successo una decina di giorni fa. OpenAL5, cioè un gruppo di 5 reti neurali artificiali, non è che ha sconfitto, ha sterminato i migliori giocatori umani al videogame Dota 2. Un videogame nel quale si fronteggiano 2 squadre di 5 membri ciascuna e l'obiettivo è distruggere la fortezza avversaria preservando la propria. Fondamentali in questo gioco sono l'implementazione degli skill dei membri, la visione strategica per arrivare all'obiettivo, organizzare la battaglia, e il gioco di squadra. OpenAL5 in pochi mesi ha giocato, imparando a giocare, l'equivalente di 180 anni di partite, in un videogioco che in ogni momento ha a disposizione 1000 mosse contro le 35, ad esempio, degli scacchi. Ha battuto, sterminandoli, gli umani, i migliori umani che abbiamo, ma soprattutto dimostrando di essere superiore infinitamente ai team umani per quanto riguarda il gioco di squadra, perché ogni rete neurale artificiale si mette totalmente a disposizione delle altre per il successo delle altre senza se e senza ma, cosa che tra gli umani non sempre avviene. Quindi, piccolo esempio per dire come l'intelligenza artificiale e i big data stiano cambiando il nostro modo di pensare, di lavorare, di vivere. Molte aziende vorrebbero essere dei pionieri della data-driven economy, ma solo poche ci riescono. E sono quelle poche che riescono a far diventare questi temi priorità del top management e a trasformarle in cultura pervasiva dell'azienda. Allora, qui con noi abbiamo veramente un numero 1 su questi temi, and I'm really happy to call Mr. Kenneth Cukier, Senior Editor of The Economist and co-author of the bestseller Big Data. Please.
Good afternoon. Sadly, I do not speak Italian, but I speak a language that's just as important. And maybe for all of you, more important, I speak data. But I love information so much that everywhere I go, I've got to collect a little bit more of it. So what I'd like to do now is ask you a question. I want to start by asking a question, and I'd like you to raise your hand. The question is this, and then I'll poll you. The question is, who here thinks an algorithm can do their job better than they do? It's going to be yes or no. All those who think that an algorithm will challenge them for their job in the next 10 years, raise your hand. Raise it, come on. Okay. All right, so that looks like 21.3% of you. Who here thinks that an algorithm cannot do their job at all? Your job is safe. An algorithm will never do your job. Raise your hand. Okay, so that's fewer. So already we can see that there's a diversity of opinion, but most people believe that in the world of data, algorithms will be doing things that people will do. I think that's true, but I do think that we're still going to have jobs. What I'd like to do now, to close the next summit, is to think about how data is transforming business, how data, AI, and machine learning is changing society and all that we know. And I'd like to begin with a story, and the story is of automotive racing. Okay? So car racing in Europe is Formula One, but in America, where I'm from, it is stock car. And in a stock car race, it's driver against driver, because the cars are roughly the same. And one of the biggest decisions you have to make when you're a driver, or more importantly, the race coach, is what to do when a yellow flag is thrown on the track. Because a yellow flag means all the cars have to proceed cautiously, and no car can pass another. They all slow down. And the natural distribution of cars along the track starts to cluster. They get tighter and tighter. And the biggest decision you can make as a race car driver and as a race manager is when you go in for a pit stop. Because when you go into the pit with a yellow flag, you do not lose time, but you lose rank position. And you need fresh tires, new tires, for speed if you want to pass after you come back out. So what do? For years, racetrack managers have been thinking about this and making decisions based on information and mostly instinct, judgment, experience, superstition, luck. Until Cynthia came along. And this is Cynthia. So Cynthia does not look like a race car driver. Cynthia does not look like a race manager. She's not comfortable in a pit with the mechanics. Cynthia is a geek, one of the best in the world. And Cynthia realized that this was a really interesting problem if you have a lot of data. So she collected a lot of data. And she looked at absolutely everything she could related to the car, the weight of the car, the speed of the car entering into the pit, leaving the pit, how many cars were clustered together, the weather. And what she realized was to answer the question of whether to go into the pit or not, she had to learn something else. She had to learn the wear on tires. And what she discovered when she studied the wear on tires, how much tires decay over time during the race, was that in fact, there is no such thing as a racetrack. There are race tracks, plural. Every racetrack has a different wear on tires. And so what the right answer is, isn't a question of what to do during the race at a given time. It all depends on what track you're racing on. And this is something that was never known before, because some racetracks wear down the tires quickly and others slowly. What does this mean? It suggests we're in a new world in which there's no one right answer anymore. The answer is contingent on the environment that you are in. Every store is different. Every customer needs to be treated differently, and it can be with these new tools. So what's going on? What is happening? Part of the story is technology. We can do new things. Another part is data. We have new information that we never had before. But the third and most important is the mindset. Cynthia Rudin had a big data mindset. She understood that if she had the skills and the humility, she could unlock new forms of economic value in the data. The lesson is that the data has become a resource. It is a new vital economic input. It is a new raw material of business. Traditionally in economics, we thought of land, labor, and capital as the three factors of production. And we can sympathize that Adam Smith didn't see information, because back in the 1700s, it was so difficult to collect, store, and process the information. But today, those three constraints have largely gone away. So we can do new things with information that we never could before. So what is the definition of big data? What does this all mean? Generally, we can simplify it to say this. There are things we can do with a large body of data that we simply cannot do when we're working with smaller amounts of it. That a change in scale leads to a change in state. That a quantitative shift leads to a qualitative shift. Or if you prefer, more isn't just more. More is different. So what does more look like? More looks like this. You can see that back in the year 2000, we like to think we were living in the information society. We were doing so in name only, because the amount of stored information in analog form, like books and like Post-it notes and vinyl LP records, was vastly larger than the amount of digital information. But analog information, which is still growing, grows linearly, and digital information grows exponentially. So by 2002, there was parity, and after that, game over. And these trends don't seem to be abating. So what could we do with all of this information, and how does it work? There's lots of techniques under the hood of what we call big data, but the one I want to talk to you about now, today, is called machine learning. Now, machine learning is a branch of artificial intelligence, but the reason why we're talking about it today is classical artificial intelligence from the 1950s and the 1960s and 70s didn't work. It was trying to recreate the human brain in hardware and in software. It's a hard problem. You have to encode everything and program everything you want the computer to do step by step as if it was a person thinking. Too many exceptions. Hard problem. Instead, they transformed the nature of the problem to one of collecting the data and inferring what to do rather than explicitly programming the computer what to do by finding patterns in the data. And so machine learning, which didn't work in the past, now works today. To give an example of what this means, it's useful to understand how it was created. And the inventor is Arthur Samuel, and Arthur Samuel was a computer scientist in the 1950s in IBM. And what do you do if it's the 1950s and you're a computer scientist at IBM and you like to play the game of checkers, but you write a program to play the computer in checkers? And so he does. He writes the program, he plays the machine, and he wins. He plays the machine, he wins. He plays the machine, he wins. Because the machine only knows what a legal move is. Arthur Samuel knows something else. Arthur Samuel knows strategy. So he writes a small subprogram that operates in the background. After every move, it calculates that the new board configuration is likely to lead to a winning board or a losing board. It's a large probability table, but intricate. He plays the machine, he wins. Plays, still wins. And then Arthur Samuel leaves the machine to play itself. The machine plays itself, it collects more data. It collects more data, it increases the accuracy of its predictions. And then Arthur Samuel returns to the machine and he plays it, and he loses, and he plays it, and he loses, and he plays it, and he loses. And Arthur Samuel has created a machine that exceeds his abilities in a task that he taught it. And this idea of machine learning is going absolutely everywhere. One place it went is in DeepMind's AlphaGo system, which was just a more sophisticated version of machine learning. The best poker player now is no longer a human, it is now an algorithm. And we use machine learning absolutely every day. Were I to Google the name of an important executive in Italy who runs a large data company, and I misspell his name, and I use 2 L's and not 1 L, as it normally is, how did Google know? Who at Google instructed the system, uploaded all of the company directors and officers of all the Italian companies and all the companies in the world Now, no one does that. It's not someone's job. Instead, you can see that in 0.35 seconds, Google has scoured the entire global internet and has identified roughly 250,000 results, and it noted that the word pair, these two-word instantiations, are far more likely with one L than with two Ls. And this is the global internet. So there's typos everywhere. You know there's mistakes. That's there. And if I click on the two Ls, I'll probably find something. But Google could make a prediction that that's what I wanted. It was a machine learning algorithm. It was programmed to identify just this sort of thing. It's because of machine learning that computer translation now works. Speech recognition is no longer so laughable. We have self-driving cars. Recently, there was research at Stanford and Harvard, and they wanted to identify whether a machine learning algorithm could perform as well as a human pathologist in diagnosing severe cancer. So they uploaded lots of samples of biopsies and the patient survival rates. And sure enough, the machine learning algorithm did work as well as a human pathologist, but with a twist. The algorithm identified 11 telltale signs that best predict that there's cancer. The medical literature only knew of 8 of them. 3 of the things that were spotted by the algorithm were invisible to the human eye, but it was spotted by AI. So if you're a pathologist, look out. Because if what you think you do to bring value in life is making decisions based on your education and your training in conditions of uncertainty, you have a problem. An algorithm will do it better. But it's not just pathologists, it's all of us. Whatever we do, if we make decisions based on our training and our experience under conditions of uncertainty, an algorithm probably will perform better than all of us too. And it doesn't mean we will lose our jobs, but it does mean that we have to re-earn our jobs by identifying what else we can do that brings value to our work. So this is a story of hospitals, and it's a story of humans. Of course, it's not a story about hospitals, and it's not a story about humans. It's about something much more fundamental. It's about thinking of the world in a new way. Every leaf, every gust of wind, every heartbeat, every lap around a racetrack, every sales transactions, every plane that takes off, thinking about the world as a platform for the collection and analysis of data. So what is the value of data? Well, in the past, the value of data was the primary purpose for which it was collected. But in the world of big data, it shifts to all the secondary purposes for which the data can be put. So think about this. Walmart collects information of its past sales behavior because it needs to do it for bookkeeping. Several years ago, it married its big database with weather patterns and identified that when a storm was approaching America's Northeast, not only would supplies of storm supplies like flashlights and batteries increase, but also supplies of Pop-Tarts, the sugary American breakfast treat. Okay, so we don't know why that's the case, but we do know that whenever they saw the storm coming, they could stock the Pop-Tarts alongside the flashlights and batteries to speed customers' time in and out of the store and to increase sales. The value of the data had become the reuse of the data. The data had become a corporate asset. And there's lots of ways in which companies are looking at the world in an entirely new form through the lens of the data that they hold. So Caesars Palace is the big casino group in Las Vegas, and it went into bankruptcy. Its creditors had identified that the most valuable asset on its books was the data that it held. It was valued at $1 billion, $1 billion for just its data. And the bankruptcy judge decided that, in fact, it might actually be worth it, but only to Caesars Palace. Give that same data to any other casino group, and they may not be able to extract as much value from that. And so the bankruptcy proceedings continued. Likewise, there is a company that is able to look at airlines and measure 120 billion flight price records, every seat on every flight in all of American aviation for a year, to identify whether a given price is likely to go up or likely to go down, telling you as a customer whether you should buy it right away or you should wait because the price is likely to decline. It's a great business, but you just know that when they created passenger records in the 1960s, never for a second did the airlines think that their own data could be used against them to undercut their business. There's a large retailer in Britain that is able to take all of its information and it's able to look at sales transactions and see the early signs of the onset of dementia, because it can identify when people then, later, use dementia drugs. And it can see how these patterns shift over time and who is walking down that tragic corridor. But sadly, still, privacy regulation gets in the way from using that information because no one gave their consent for it to be used for this purpose. So we need to rethink the rules once again. What this all means is this, that just as we have sequenced the human genome to understand the human body and health, we are actually creating a genome and sequencing a genome for society through the lens of data, by understanding absolutely everything that can go on in society with the facade of data and the insight of data to extract new value from it. And when you use the data, rather than keeping it held close, it creates a multiplier effect. Just as if you were to take money and put it into under a mattress, it wouldn't circulate through the economy, but if you put it into the banking system, it's a system. And there's a multiplier effect to the currency that it circulates throughout the economy multiple times, swelling the money supply. Likewise, data has those same properties. It becomes more valuable when it is used. What are the implications to all this? Well, the first is that it means change. Change for organizations and the people who work for them. What you need to know changes. Who you need to know changes. Who your friends are will be different. Who your rivals will be different as well. But interestingly, there is an advantage for established companies. And this is different than at the outset of the World Wide Web. In the 90s, the advantage shifted to the startups because they were unencumbered in the legacy business models of brick and mortar companies. But in the world of big data, what it takes to be successful is to have information, have the data, and so the advantage shifts to companies who have been around for a long time. And this is particularly good news for Italian companies, because you are looking in the global economy for ways to extract new forms of economic growth, and you have lots of companies, particularly small and medium-sized enterprises, that are excellent at what they do. They need to start collecting their data and putting it into a system, probably creating cooperatives to share the data and competing against others. And if you can do that effectively with partners, you're probably going to succeed. Now, this has been the optimistic part of the story. There's some downsides as well. And the first one, of course, is privacy. Privacy has been a problem in a small data world. It is a problem in the big data world as well. And we need to rethink how we interact with information to make sure that we actually handle customer information responsibly. The Cambridge Analytica story in Britain is an example of what not to do. The second is ownership. Who owns all this information? Is it the person from whom it was taken, or is it the company who invested a lot of money to analyze it and create new products and services around it? Here, America and Europe are going in different directions, and it's not quite clear where it will end. Thirdly is propensity. The idea that we may be punished by an algorithm prior to actually committing an act because we will be predicted to do something that we haven't yet done. A little bit like Minority Report. So just as we had to safeguard administrative judicial fairness in the 20th century, we probably need to safeguard human volition, human agency, and free will in the 21st century. And finally is the question of what we'll call dataism, because there's no good term for it. And this is most important. We need to embrace big data for all the ways in which we can benefit from it, but we also must remember that we have to be the masters of this technology, not its servant. And though we use it, it doesn't come at the expense of our values, our sense of fairness, our sense of what is just, our common sense. Because the data is only a representation of reality. It's not the real thing, like a map is not territory. So we use big data with caution. So what's coming up next? Well, we're going to be using data and artificial intelligence and machine learning to solve a lot of our global challenges, from how to respond to climate change, to how to cure disease, to managing our cities, to managing our share portfolios. But what's really important is as we transform every aspect of society in business, this is how companies are going to succeed, compete, and win. Thanks a lot.